Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of domain by evaluating a few basic functions. We're not going to go too complex. We just want to make sure that you understand the concept, all right? So let's get started. When we look at this first problem, right off the bat you should ask yourself, are there any denominators or square roots? So in this case you can see that there are no denominators, there are no square roots or even roots, and our x is absent from the ln of 2. So this is just a number, 0.69 blah 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 blah, 3 something or other. You can get your calculator and figure out what it is if you want to. But the point is, it's not a variable, so there's no restrictions for natural logs. Since we have no restrictions of square roots or denominators, and the x is absent from there, we can just say the domain's going to be negative infinity to infinity, where all real numbers symbolized by this big fancy R. Okay? So let's try another problem. These are all, again, just introductory problems, nothing too special here, just things that you should keep an eye out, how your mind should be thinking when you're approaching all domain problems. So let's see. There's a second problem. Right off the bat, you should see that there's a denominator, that 2 minus x is along the bottom. So what do we do with the denominators? Again, what you got to do is you got to set the denominator not equal to 0. So denominators cannot equal 0. So set this not equal to 0 and solve for x. Okay, so let's see that in action. That should be something you can do pretty easily at this point in your math career. If not, then you need to go practice. So let's see. So there's your 2 minus x, your denominator. Subtract 2 on both sides. And you're going to get that. And we want x, not negative x, so we got to divide both sides by negative 1. And when you do so, you get x cannot be 2. All right, so everywhere else a function is defined except for 2. So the way we write that would be, so if you were to do interval notation, you get the following answer. You'd start at negative infinity, never use a bracket for infinite values. You cannot ever include infinity or negative infinity. Here we go until 2 because we cannot equal 2, but everything else is defined, so we start back at 2 and then go to infinity. If you did a number line, it'd just be everything shaded with an open dotted 2 for this one. That's why I didn't do it. Okay, it's not too complex. Hopefully you can see that. All right, so our final problem is going to be a square root, and nothing too complex here. It's just a linear function under the square root. So whenever we're solving this, all we have to do with all the square roots is just take whatever's here and set it greater than or equal to 0, because we cannot take the square root of a negative number. So that greater than or equal to 0 in action looks like this. Because the power of x is 1 and there are no fractions, we can just solve this. There's no sign analysis required. So subtract 4 from both sides, you get that. Divide by 2 from both sides, you get that. And if we were to plot it on a number line, it would look like this, where this is your negative 2. And notice we have a closed dot because of the equal sign. This is a closed dot. So if you were to look at that final answer, it would be basically this in interval notation. We'd start at the negative 2, include it with a bracket, and then go all the way to infinity with a parentheses. All right, so that's the introduction to domain through examples. Practice some on your own. They do get tougher than this. I just wanted to open the door for your doubts to be alleviated and for you to be able to practice some problems on your own. All right, check out the intermediate and advanced videos, and as always, remember to practice, practice, practice. Thanks for watching. Have a great day.